Yeah, I think it's okay. Uh, Just where are you? The room is looking something different. Your room is
So like this only.
what, Sana?
So it is like this only.
No, no, it's looking like that you are is sitting in the school something.
No, no, not true.
Okay. Now see here, we got the topic here. The topic is what that is temperature dependence rate of reaction. Okay, temperature dependence rate of reaction, that is also called Arrhenious equation. Okay,
Yes, sir.
what the Arrhenius, some points he gave, the important point he gave, that is very important. Okay, what are the point are there? That is, they are saying the rate of reaction with rise in temperature increases. Okay, it has been observed that a chemical reaction rate is increases 2 to 3 times with the 10-degree rise in temperature. So that is the first point he gave. That is, if suppose here that is what is the initial temperature, 0 degrees there. Okay. So here talking, that is if you are increasing the this one by 10 degree. So rate is going to be what is happening. That is final rate is going to be the 2 times of this one. Means here you see little not visible to you. KT is there, na? KT plus 10 degrees there are divided by what we are having KT. So it is going to say, they are saying that is you increases 10, then it becoming the 2 times. So KT is equal to, KT plus 10 is equal to 2 time KT. So rate is becoming the 2 time, rate constant become the 2 time. That is what the point. Now, some points are there, that point are important point that we have to understand. What they are saying, that is the Arrhenius reaction is what quantitative relationship between the rate constant. This is the rate constant and what is their temperature of the reaction. So Arrhenius reaction gives the information about the rate quantitative relationship between rate constant and temperature. Next one point here, they are talking about according to Arrhenius, a reaction can take place only when reactant molecule collide to each other. Okay, this is what the concept. That is when the reaction. Hello,
Audible, sir.
sir, taking class, sir. Wait, sir. Huh. So here the point they are talking about, when the reaction will take place somewhere, until or unless they should collide here. Okay, these two should collide. Then only reaction is possible. Then only reaction can takes place. If these two molecules are not colliding, they are going this side and this molecule is going this side, there is no reaction. Reaction is not possible. So collision should be proper orientation. For example, if I will take the example, let me move this one. Okay. The collision should be proper collision. Suppose if the molecule is like that, head to head colliding, this one, head to head colliding, this is the proper collision, proper. And it will give rise to product. For example, I am taking the example. Suppose here is what is there. Carbon is there. This is the hydrogen. So here is hydrogen. This is the chlorine. Here is hydrogen. If you want to react the this OH group from the front, okay. So this is also the chlorine is negative. This is also negative. So here is a repulsion will be there. Both side repulsion. So this is called improper orientation. Improper. They are the improper orientation. And improper orientation, they are not going no product. It is not going no product. It is not going to give the product. Okay. Then what? Then what will be there? Then OH should attack from the back. Okay. This
Yes.
one. Which type of reaction is this one? SN1 or SN2? Now you see this carbon is partial positive and this is partial negative. Now this it can attack here.
Sir, if you're writing anything, it's not visible to me, sir.
Not visible.
No.
Abbo. Why it is not visible to you?
Sir, you can try like switching off the screen sharing and starting it once again. Sir, I think it is frozen, sir. Not
Now.
now also not visible.
Sorry. Now.
Now coming.
Sorry, na.
No, it's
Ha. So here you see, this is in this case, what is happening here? That is, this is the improper. Minus minus is there, na. Here will be repulsion. So orientation is not good. But if it is backside attacking, it will give rise the product. Okay, this is the C, here is H, this is H, here is H, plus Cl minus will be out. So this is giving the product, but this is not giving. Why? Because the collision should be proper collision. That will give, that must be effective. Okay, what is the reaction? Do you know what is the SN1, SN2 reaction? Did you study?
no, sir.
Acha, organic they did not start in your school.
Sir, when? Sir, in our school also, this one is only going on. Chemical
Oh,
kinetics.
okay, okay. So solution electrochemistry over, they finished.
Yes, sir.
Okay, okay. Now they see the point number, the first point already we have done. Arrhenious reaction can take place only when reactant molecule collide. Reactant molecule, if it is colliding each other, then the chemical reaction takes place. This is the first point. What the second point he is saying? The collision of reactant molecule form an unstable intermediate which exists for short time and breakups to form the product. So when the collision taking place, the firstly they are going to form the intermediate. Okay. What the intermediate is called unstable intermediate. And the lifetime of that intermediate is very small. For example, see here, H2 molecule, this is I2 molecule. They are forming the intermediate where the old bond is breaking and new bond is being formed. You can see here, new bond is being formed. Old bond is being break. This is unstable and short time. This is going to be short time. And finally, it very fast, it will convert into product. So here is the HH is there. Now it becomes the HI, hydrogen iodide. Means the reaction is H2 plus I2. It is going to give 2HI. This is the new product. Earlier, the bond was like that. H bond H plus I bond I. Then they form the intermediate. How the intermediate forming? This is the H. Here is the H. Then old bond is going to break and new bond is going to be formed. Here the new bond is going to form. Now, finally, it is going to break. So it will give what? That is the HI, one molecule, plus HI, another molecule. So this is what they are saying. When the collision, they collide, when the reactant molecule collide. So what they do? Intermediate formed. Intermediate means that is transition state. Transition means state means high energy state. High energy state means that is unstable state. So these are the sequence. So unstable means it is resulting to the product. So these are the point. Now the third point is extremely important. Third point, you see, reactant molecule required some amount of energy to form this activated complex. Which one? This intermediate complex. That is intermediate. The energy required to form this intermediate is called activation energy. This is activation energy. So activation energy is minimum amount of energy which is required to form the activated complex or intermediate by the reactant molecule is called activation energy. Please note this one, this point. What is the activation energy? This is the minimum amount of energy required to form the activated complex by the reactant molecule. Is it okay?
Yes, sir.
Next point, they are saying energy is released when activated complex decomposed to form the product. Profile of energy when reactant go into the product represented by the. Now the point is very important here. The last point, they are saying energy should released when it is forming the when the this activated complex intermediate is converting into product. So let me explain to you. Okay, you might be able to understand this one very easily. What is the problem here, Sanay? When the bond is getting formed, na, new bond is being formed, na, that is exothermic. This is what is called exothermic. Exothermic. Yes, yeah, no?
Yes, sir.
Here is what is happening when the reactant molecule approach. So because here the electrons are there, both the electron, so there will be repulsion. And repulsion increases the energy level. Repulsion increases the energy level. So here in this intermediate where the new bond and old bond are being formed. So old bond breaking, new bond getting formed. So this is high energy. This is the energy, high energy. Okay, high energy. See this one. Reactant unstable intermediate exists short period of time. So this is there. High energy, that is why the short time, na. That is why it is the unstable, na.
Yes.
Anything which is high energy, that is unstable. So this is what high energy they are talking about. This intermediate is going to be unstable. Now, what is happening to become the stable energy must lose. So when this is converting into product, that is loss of energy takes place, loss of energy. And loss of energy means bond formation is exothermic process. So this is what is the plus heat is going to be liberated. If heat is liberating, so this molecule is having less energy, that is from the stable product. So you can read once more. Energy is released when activated complex decompose to form product. Up now see. Here is the energy of activated complex. Can you see? This is the activation energy. Here they form the activated complex. Right? This is the reactant molecule. Now, when it is decomposing, so you can see the product is going to be the lower energy. Here they see the energy gap. Here, this is the energy of the reactant molecule. When it is decomposing, when this one activated complex decompose, it gone down. Can you see this line? It gone down. So this is the one, the product is having low energy. Product is having low energy. So they are saying that is when the activated complex, this is the activated complex. Activated complex. When the activated complex decompose, it's lose the energy. It means the product is having what? Low energy. This product is having low energy. So this is the potential energy graph they have given. Is it okay?
Yes, sir.
Huh. Now, some more points are there here, Sanoy. This is the same graph,
So
na?
you can show the diagram also. Then.
Please, see.
I will write, sir.
No problem, no problem.
Yes.
Done.
No, sir. Sir, I actually did it once, but sir, it was wrong. So
Okay, no problem, no problem. Take your time.
done, sir.
Okay. So this is the for the exothermic reaction. This is the exothermic. Means the air energy loss. Now let us see the endothermic, how the graph is there. Endothermic. This is the activated complex. Here is the product. Similar graph is there for exothermic, endothermic. There is nothing more, not difference is there. Here you see, so now the next point. This is also important one. Fifth point. This point asks.
One second, sir. Please. Sir, exothermic, endothermic graph once again, sir. Sir, I did not see that one.
This is the endothermic now. This one.
No. I mean, sir, I'm just noting the whole thing down, sir. If I don't write this, then there will be problems with this.
No, they generally they did not ask till now. This one graph one. Only the graph of activation energy they ask. Activation energy. This one. Till now we have to study so many theories. Nothing to worry. We have to study the theories. It will take 2 days. 1 more day. 2 days and 1 more day. Then it will be over. This chapter.
But sir, other chapters also, sir, I am doing also myself, sir. When you will do, then whatever there will be the problems in understanding, that we will clear. Sir.
Whenever your exam is there, one week, at least 10 days before you inform me. Whenever the chemistry exam is there in your school, 10 days before you
Chemistry
inform me.
exam is there in school on Monday, sir.
Uh,
Electrochemistry. From
this
electrochemistry it is there.
electrochemistry, not solution.
No, sir, not solution.
Okay, then electrochemistry problem we solve. I think we solve all the problem. Are there
Yes,
any
yes,
problem?
yes, sir. Sir, I solved NCRT, sir.
Okay. In case of any problem, you let me know.
Yes, sir.
Okay.
Sir, I am telling that the advanced chapter, sir, that because today I was studying the surface chemistry. Sir, I
Uh-huh.
did not have any problem in understanding. So, sir, when you will teach me this one, sir, then
Surface chemistry is not there in the CBSE.
okay, it's not there.
Don't read unnecessarily. Probably it is not there in the NEET also.
New syllabus has come out, sir, nationalized syllabus.
Last year also, in the NEET it is not there.
No, sir, how to get that syllabus, sir? I did not find that syllabus. I searched in many places.
Syllabus it will be there on the CBSE side only. CBSE side only.
CBSE
Okay.
said, sir, new
CBSE
syllabus.
side. CBSE side means that is the NTA, National Testing Agency. Okay, I will find out. I will share you. Don't worry. I will find out. I will share you. I will share you. CBSE syllabus is there with you. CBSE. It is also not there.
CBSE syllabus is there with me, sir.
So CBSE this chapter is not there now.
So I did
Uh,
not check actually, sir.
no. Don't waste your time. Here you see. Now fourth point. This is asked in the 2024 exam. This one. This all asked in the MCQ. See the all the molecules in the reacting species do not have the same kinetic energy. The fraction of molecule with a given kinetic energy is calculated by Boltzmann's and maximal statics. That is how much energy is there? E power minus EA upon RT. E power minus EA upon RT. This is the correct option is there. Other option is there. That is AE power minus EA upon RT. One more option was there. This was wrong. And this was the correct. Okay. So fraction of molecule with the given kinetic energy is calculated by this equation. E power minus EA upon RT. I shared you the question paper also now, Sanoy.
Which one, sir?
This year question paper.
Probably not, sir, but even if that, I will check, sir.
Wait. Let me find out. I myself found out. I shared you the previous year board question paper. I shared you. Where is that? Yeah, I got the question paper. Wait, let me discuss some question. If we discuss this one, it will be helpful to you. Question number. Yeah, this is not. Yeah, this is your question. Just finding the question. Is there? 1 minute. Just you give me 1 minute.
Okay,
No.
sir.
This is also not. I need to find out because I shared this year board question paper. I shared you, yeah. This year question paper I shared you. I think you forgot everything.
No, okay, sir,
Uh,
I will check. I have the WhatsApp here only, sir. Let me check, sir. It must be here only, sir, if you have shared.
the 12th question. No, this question I just wanted to discuss with you now. That is why I'm searching. Otherwise, I need to go. What is the name of Red House Capstar? Red House Sanchi. Just give me 1 minute. Yeah. What I'm doing, I'm just sharing this one to you. WhatsApp. So,
But I am also searching, sir. Here I did not find this one, sir.
wait,
This
wait,
book.
wait, 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 wait. So, just I already downloaded. Nothing to worry. Just when you are together, you are doing any problem now during the class time itself. So many things will be covered. Many things will be good only. Uh, I see here now. There it is gone, yeah. See, sometime what is happening, we do study many things, but if anything miss means the problem comes. Huh. Did you see in your book just WhatsApp
Yes, sir. Found.
found? You say the MCQ questions. This is the MCQ question only. If the slide is visible, that is what I opened to you.
Ah, yes, yes, sir. Visible, visible.
So see, Sanoy, the first question you can easily solve. This question you can easily solve. First one, based on the Kohler's law. So I am not discussing this question.
Addition,
Uh,
means addition.
uh, uh, this one. Here, this one. This question is, Sanoy, the correct mathematical expression of Arrhenious equation that we will be dealing with, K is equal to AE power minus this one. This is there. This option is there. That will come. One more question is there. Fraction of molecule. This graph we discussed. See, this graph already we have discussed slow. If you remember. Okay. So whatever the possible questions are there, we are dealing here. Or this question is not there or what? I think the question is what I am looking for. This they may be given in the other set. Here not there. Kindly go once more. So this slide you go na many of the question you will be able to solve. Now let us move out next. Next point. The distribution of kinetic energy may be described by plotting a graph between fraction of molecule and the kinetic energy. So this is the molecule, fraction of molecule having highest kinetic energy. They are talking about fraction of molecule and they are talking about kinetic energy. So initially kinetic energy is increasing, then kinetic energy is decreasing when the product is being formed. Here they are saying peak of the curve correspond to the most probable kinetic energy. This point is most probable kinetic energy. So this point is not going to be very important for you. This is, let me deal now. Directly you come to the, this one, derivation. So we are doing the derivation now. What the Arrhenius said, Arrhenius firstly give the empirical equation. This is the empirical equation. The rate constant of a reaction at a given temperature T is given by Arrhenius equation. K is equal to AE minus EA upon RT. This is the equation. K equal to AE minus EA upon RT, where K is the rate constant, A is the Arrhenius factor, that is called frequency factor. And the next one point they are saying, this is EA is the activation energy, joule per mole, and is there, R is the gas constant. Now, this is the equation. This is the equation is empirical equation. Empirical equation. Empirical equation means this equation is obtained by putting the values. Okay, empirical equation. Now this equation we have to derive. So what I am writing here, derivation of Arrhenius equation. This here I am writing derivation of Arrhenius equation. Derivation of Arrhenius equation. Arrhenius equation. So, Sanoy, what is the derivation of Arrhenius equation? Firstly, given K is equal to, you can see the equation here now. This is the K is equal to AE power minus EA upon RT. So here we can write K is equal to AE power minus EA upon, this is the RT. Okay, this is the equation. Now, what we have to do, Sanoy, this equation, what we are going to do, we are deriving. How we are deriving? If I will talk about at T1, we are going at T1. And here we are going here at T2. At T2. Now, we got to know if we increase or decrease the temperature, rate constant will automatically change. Yes or no? If you increase the temperature by 10 degree, so rate constant will become twice. So here you see what we can write. Rate at T1, rate constant will be K1. Rate constant. I am writing rate constant will be K1. And here at T2, rate constant will be K2. Right? This is. Now we are taking log. Both the cases we are taking log. Okay? Taking log. Both the side we are taking log. Okay? Taking log. So at T1 we are taking. So what is log? What is going to be K1 is equal to log A plus it is the log, don't take log. Simple you take ln. Directly log we cannot take. Always we take the natural logarithm. Natural logarithm is ln. So ln K1 is equal to ln A plus what we can write ln A into B. It is A into B means A plus B. So ln E power minus EA upon RT. This is there. This side, this is equation number 1. Here you see equation 2. That is ln K2 is equal to ln A, right? ln A plus what will be there? ln E minus EA upon RT. This is the RT1 and this is going to be RT2. Now, Sanjay, one more point you see kindly. So, ln A power n is equal to what is there? Can you tell me? ln A power n.
A power n is n ln A.
N ln A. Okay.
Yes.
Log ln E. ln E equal to, this is going to be 1. ln E equal to 1. Okay. Kindly see in a little bit, but be focused here. So here you see ln K1 equal to, this is the ln A, and then we are splitting. So minus EA upon, this is going to be RT1 and ln E is 0. ln E is 0. We are not writing this one. ln E is 1, not 0. ln E is 1. So we are not writing because if you are multiplying, if you are writing this one, then it will be ln E and ln E's value is 1. So nothing to write, there is no use. So this one is there. Now, here is the, suppose this one is one equation. In spite of writing this one 1, I am mentioning this is the 1. And in spite of writing this one, we are writing ln K2. ln K2 is equal to ln A. Here will be minus EA upon RT2. Equation number 2. Which temperature is more, somewhere T1 or T2? Which temperature is going to be more?
T2.
T2, thank you. So we are going equation 2 minus equation 1. Equation 2 minus equation 1. This one we are going. So ln K2 minus ln K1 equal to what will be the value we are writing? ln A minus EA upon, this is going to be RT2 minus, in bracket, it is going to be ln A minus EA upon RT1. This is there. Now, what is the, so now, ln A minus ln B. What is the formula? ln A by B. Yes or no?
A by B is ln A minus ln B.
Thank you. So, can we write that is ln K2 by K1?
Yes, sir, we can write that way.
Thank you. So here it is going to be ln A minus, this is going to be EA upon RT2. This is what ln A minus into minus plus EA upon RT1. So now what the something is going to be cancel out, minus ln A and plus ln A. This is going to be cancel out. Now what will be, so now ln K2 by K1 equal to, what will be, so now positive term we are writing the first. So EA upon RT1, negative term writing at the end, EA upon RT2. Now, what we will get here, some common things are coming. ln K2 by K1 equal to, this is the EA upon R. Activation energy upon gas constant is common. So 1 upon T1 minus 1 upon T2. This is the derived equation of what? That is the Arrhenious equation at two different temperature. Now, we also know ln is equal to, we are converting into log base 10, 2.303, it is log. Do you know this one, this conversion?
Yes, sir.
So here we are writing log 2 no. Firstly, we have to write 2.303. 2.303 log K2 by K1 equal to what is A upon R. We can take the LCM also. So it will be T2 minus T1 upon T1 T2. This is there. Now what we can do, we can send this numeral value the other side. So log K2 by K1 equal to EA upon 2.303. This is the R. What will be there? T2 minus T1 upon, this is the T1, T2. This is the derived equation. This is what is Arrhenious equation. You can, if you want to see, you can see NCRT also. Can you understand this?
Yes, sir.
Sometimes they ask the derivation, simply they ask the derivation also. So you have to be little bit careful. Okay. Can I
Yes,
erase? Can I
yes, sir.
erase?
Yes, sir.
Directly we are rushing to the solve the problem here. Okay. So now they are saying for the decomposition reaction value of rate constant K at two different temperature given. What is they are saying? T1 they have given 650 Kelvin and this one. And at this one K1 they have given 2.15 into 10 power minus 8. T2 they have given that is 700 Kelvin and K2 they have given what is that is 2.39 into 10 power minus 7. Calculate the activation energy. They are asking activation energy. So what the formula we can use? Log K2 by K1 equal to what is there, Sanay? That is activate EA upon 2.303. This is the R. Here will be that is T2 minus T1 upon T1 T2. This is the equation. Now we are putting the value log 2.39 multiplied by 10 power minus 7 divided by 2.15 into 10 power minus 8 equal to activation energy 2.303 and R value 0.0821 because we have to take the liter. In the liter, na, liter, ATM, mole inverse, Kelvin inverse, it will be 0.0821. If you want to see the values, I'll show you the values here. R value in the some question they have given. See, 8.31 Joule Kelvin inverse mole inverse. Wait, why Joule Kelvin mole inverse they have given? We required the liter mole inverse Kelvin inverse. Wait, Sanoy. 8.314 Joule Kelvin inverse mole inverse means the activation energy is okay. We have to write this one only. 8.314 because this energy is there na. Kelvin is there and activation energy will come out to be in the joule.
Can you please keep this slide for some time, sir? I'm writing.
Uh, it is the 8.3121. You are writing question or what?
Sir, I'm writing the answer on this, not the question.
You started solving this one.
Done, sir. Done.
Okay. Then here what is the temperature we are writing? Now T2 700 minus 650 divided by 7 multiplied by 650. This is there. Okay. R value. The R value has to be memorized, Sanoy. Otherwise, it can create the problem. 8.314. Better you write 8.314. 8.314. Now, simple is there. You divide this all the log. This is there. So we are dividing that is 2.39 is there, right? 2.39 divided by 2.15. It is coming 1.11. and this will go in the numerator. So it will come what? -7 + 8. That is multiply by 10. Means it will be 11.1. This is the log is 11.1. This is coming equal to activation energy. This is 2.303 multiplied by 8.314. And here in the bracket, it is coming, I think, 50 divided by 700 multiplied by 650. Okay. Now, what we need, the log value we required. What is log 11.1? Generally, in the board exam, log value they always give. So, log, let me find out the value, please. Log 11.1. It is coming somewhere 1.0453. 1.0453. This is activation energy 2.303. Here the calculation is a little bit, you will find big calculation. Multiply by 50 divided by 700 multiply by 650. Okay, this is there. Now we are calculating
Sir,
activation.
you keep that one, sir. You keep that one. Just
Activation energy is equal to 1.0453 multiplied by 2.303 multiplied by 8.314 multiplied by 700 multiplied by 650 divided by 50. So what I am doing, this is actually, I taken this example from modern ABC. So if you are having doubt, you can verify the answer. 2.303 multiply by 8.314 multiply by 700 multiply by 650 divided by 50. So the answer is going to be, here the activation energy is coming 19. This one is there 2.8.317. This one 2.303. The answer is coming little bit more, Sanoy. No. 50. Wait. 1.045 multiplied by 2.303 multiplied by 8.314 multiplied by 700 multiplied by 650 divided by 50. It is coming 182,079. Okay, this is the joule. Now, a kilojoule per mole, if we are calculating 182.079 kilojoule per mole. This is coming.
done, sir.
Done. Just you give me 1 minute. Let me verify the answers. Otherwise, anything is mistake, that is not correct. Just 1 minute. 182.254. 182.254. So round figure is coming. I am sharing you the solution also, because you may be confused. In case of confusion, you can see. Yeah.
Done, completed.
Okay. So now moving to the next question. You try to solve the question. I'm giving you the question here. Here the question are there in the two part is there. Two part is there. In general, it is observed that the rate of chemical reaction become double with rise in the temperature, 10-degree temperature. Okay, double when the 10-degree temperature is. Now, remaining part is here. If this generalization hold for a reaction in the temperature range 298 to 30, So they are 10 degree. Here the difference is 10 degree C, 10 Kelvin. What would be the value of activation energy for the reaction? So here they are saying K2 is equal to, they are saying 2K1, and K1 2K1 at what temperature they are talking about? This is the T2. T2 is equal to 308. And here is the K1. When K1 is there, the temperature is T1 is there, 298. Right. So some values I am writing log. It will be the K2 by K1. And here is activation energy upon 2.303, that is R. R value already given, there is no problem. T2 minus T1 upon T1, T2. This is there. So what we can do, log K2 value, we are writing 2 times of K1. It is increasing 2 type of K1 because 10 degree increase. So divided by K1 is equal to activation energy upon 2.303. This is R value 8.314 multiplied by T2. T2 means 298, 308 minus 298. Can I write the 10 directly?
Yes, sir.
Divided by 298 multiplied by 308. Now, directly, this will be cancelled out. Log 2 value 0.3010 is equal to activation energy divided by 2.303, 8.314. Here is the 10 multiplied by 298 multiplied by 308. So activation energy is equal to 0.3010 multiplied by 2.303 multiplied by 8.314, 298 multiplied by 308 divided by 10. Now, you try to find out the answer. Can you try?
This one, sir, I think we have to divide this because we shall find out the found out the value of alpha.
Use the calculator and directly divide.
This one is a bit long calculation, sir.
You use the mobile cell phone.
My pen actually fell now, so shall I just put it back?
No problem. Are you doing calculation now?
No.
Okay.
So it is called 2897.7785.
In the, can't you write on the screen? Is it possible to write on a screen?
Fine.
Only the answer you write down in the joule and kilojoule. Oh, okay. 50. Right, right. Hmm. This is the coming in June. So in kilojoule, it should be 52.8.
Yes.
Okay, thank you, thank you. So leave it. Okay, okay. So simply 52.8 kilojoule per mole. Now you see this one. The answer is also they have given. Can you see 52.8?
Same.
Okay, thank you. Now, will you try this question? Will you try this question by yourself?
This is, sir, which question rate was the first reaction?
Hmm. Here on the screen itself, you can write.
Sir, I don't recall the formula actually, sir. If you could tell me that.
Formula I am writing, no problem. Wait. K2 by K1, T2 minus T1 upon T1, T2.
Sir,
Should I
what
put the
2.33? Sir, above 2.303, what you have written, sir?
activation energy? This is the activation energy now. See the question. The rate constant for a first order reaction becomes 6 times when temperature is raised to 350 to 400 Kelvin. So they are saying that is if 350 is there, T1 is equal to 350. So rate constant is going to be K1. If the temperature T2 become how much? 400 Kelvin. So that is K2 is equal to 6 times of K1. So what we can write? Log K2. It will be 6 K1 upon K1 is equal to activation energy 2.303. It will be T2 minus T1. T2 they are talking about 400. 400 minus 350 divided by 350 multiplied by 400. Now, here you see, this one will cancel out log 6. Log 6 is equal to log 6 means that is the 2 log 2 plus log 3. Here you see activation energy. Here is 2.303. Here is the 400 that is 50 upon 350 multiplied by 400. Log 6 value simply we can add. Okay. Otherwise here the log 6 value they did not give. But let me write the log 6 value. In the board exam, generally they give the log value, nothing to worry. Log 6 value, if you see, 0.0778 is equal to, this is activation energy, 2.303. Here is R is also there, Sanay, R. R value they have given, 8.314. This is 8.314. Multiply by 50 divided by 350 multiply by 400. Here, what will come, Sanay? This one. Activation energy is 0.778 multiplied by 2.303 multiplied by 8.314 multiplied by 350 multiplied by 400 divided by 50. Now you find out the answer.
It's 400. Sir, this is 900. Sir, we have to find the EA over here, you know, sir? Consider 4 into by yes, 100. It's like 400. So there will be coming this is EA equal to 2.62.
Hmm.
41.792. 6.
Did you find the answer, Sana?
Well, you can check whether it is correct or not. So I've done the whole thing.
Oh my God. How you did calculation?
Sir, I did with the calculator, sir. Is the
But
problem is there, so you can please check whether it is correct or not.
it is correct only. It is correct only. You can also check. 41.7. Your is also coming 41.7. 100%. Exactly correct. Okay. Thank you. One more question is there. Will you try this one? Will you try this
A
question?
particular reaction triples and temperature changes from this one to this one. Calculate the activation energy of the reaction.
Hmm.
That rate of reaction means that K1, no sir. K.
Ha, ha, ha. In spite of rate constant, they wrote a rate of reaction. But they are saying it is tripling, getting 3 times when temperature is increasing 50 degrees C to 100 degrees C. So firstly, you see the R they have given in the Kelvin. So temperature
I
we
am
have to
doing,
change.
sir. You can check that one from there.
But the temperature you need to change, na? That is what I'm
Ah,
saying.
I will change. I will change. I will
Okay,
change.
okay, try.
50 degrees centigrade means 50 plus 273 Kelvin. Okay. 273. 273 Kelvin. T2 equal to 100 degrees centigrade equal to 100 plus 100 equal to 373 Kelvin.
Where you are doing, it is not visible to me.
It will come, sir. Just so it will come all together at once.
Okay.
Ocean energy. Now, sir, it is log K2 by K1, no?
Log K2 by K1. Yes. K2 by K1 means K1 will be
We have to
cancel out. Log 3 will come.
yes, sir.
Hmm.
Log K2 by Km equal to EA
Hmm.
by
2.303 R
304
T2 minus T1. T1.
E2 minus E1 by T1 K2. K2 equal to 3K1. Log 3. Sir, what is the value of log 3, sir? It is not given.
It is given here, you see.
Yeah, I got.
Huh.
EA by 2.303 into 8.314 into T by T1 T2 will be A equal to block 3 will be coming downwards, and this will go equal to. Sir, what they give the value of block 3? 0.477.
Yes, yes.
471 into 23, 373, this one, divided by 2.3. One also into 250. Also, we can for EA will be equal to this one. 2201.
आज मैं आप सभी को सब ड्यूरल हेमोटोपा के बारे में बताना चाहूंगा। सब ड्यूरल हेमोटोपा एक प्रकार का ब्रेन इमेज है। दिमाग के ऊपर तीन चादर है, ड्यूरा मैटर, बाया मैटर, आर्चनॉइड। ड्यूरा मैटर के नीचे में
Sudden.
इसमें खून का रिसाव होने के
So your is also coming the same, no? What I did.
Yes.
So you are using the calculator. What calculator are you using? This one you are getting.
Sir, I just multiplied the top and divided the top, sir. Divided the bottom one.
Which type of calculator you are having? Scientific calculator or what?
Sir, normal calculator, sir. I am operating with my tablet.
Acha, 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 acha. I don't know how you are operating. That is what. The
Why,
answer is hmm?
why, sir, like that? I did not understand, sir.
Now how you type this one? It is the typed one, na?
Sir, that I am doing with the Zoom only, sir. It is possible over here.
So with the Zoom it is possible, no?
Yes, possible.
Okay, okay, okay. Thank you, thank you. Now what we are doing, we are checking the answer whether it is correct or not. So it is absolutely correct. 22.012.
22.011. Yeah. Okay, same only. Sir,
Hmm.
same.
Why they are using this one? Why this one? Joule per mole is there, na?
Sir,
So
I
in the
think this will not be there.
that is
Joule
wrongly there.
means we have to multiply by 10 power minus 3 to get kilojoule per joule.
हाँ. Now one chemical kinetic. Just you give me 1 minute. See it. You remove your typing one. Can you? Here the temperature dependence. This the statement you can know once you read this all the points. You will be able to understand this all the derivation. Here questions are there. Two more questions are there. Okay. So some question you try to understand. Tomorrow we will study the effect of catalyst and all. This will be over. Very few lines left here. Then one thing is I want to tell you, this is pseudo first order reaction is there. What is the pseudo? Pseudo means false. Pseudo means false. Okay. Like the pseudopodia is there in the amoeba. That is called false leg, false food,
Yes,
false
sir.
leg. Okay. Similarly, this reaction is what that is pseudo first order reaction. The reaction is supposed to be high order, but it follow low order. That is what the pseudo order reaction. It it appears to be a higher order. It appears to be higher order. To be higher order, but follow low order kinetic. Low order kinetic. So if you are following low order kinetic are called, what is called, this is called pseudo order reaction. PSE, pseudo first order reaction. They are the first order reaction. Generally it will be the pseudo first order reaction. If you see, the order of reaction is sometimes altered by condition. What is? Consider a chemical reaction between two substances when one reactant is present in large excess. During the hydrolysis, 0.01 mole of ethyl acetate in 10 mole of water. So now see which one is excess. Can you see? 0.01 is there, ethyl acetate, 0.01, very less. This is the very less. And here is 10 mole is there water. This is the large. This is going to be large. So amount of various constituents at the beginning T is equal to 0 components of the reaction given. So here is T equal to 0. 0.01 is there. Water is 10 mole. So it is the initially when time equal to 0. So no product form. T equal to 10. It is the 0 mole. It is left 0 mole. It is the H2O is 9.9. This is the product is forming. Now you see what the point they are saying. The change in the concentration of water is very small. Getting my point? Change in the concentration of water is very small. So this is not going to be considered because if the change is not too large, it is very small, so it is not going to be considered. So the order of reaction is going to be depends on only one molecule. So although it is appear to be these two molecule order two, but it follow one. Now see the concentration of water does not get altered much during the course of reaction. So in the rate of reaction, how you can write rate is equal to K dash concentration of ethyl acetate plus water. This is 1 plus 1. It should be that is 2. The term H2O can be taken as constant. So H2O, this is becoming what? That is constant. The equation thus become the rate is equal to K. This one, CS3, C double O, C2H5. This become the constant. Water become constant. Its concentration is not changing. So here it is appearing to be 2, but concentration is not changing. So actual order if you are finding, actual order is 1. So although it is appear to be second order because water is there here, but it follow the first order because water concentration is not changing. So this type of reaction is called pseudo order reaction. Here you see. And the reaction behave as first order reaction. Such reaction is called pseudo first order reaction. Now here one more example they have given. Inversion of cane sugar is another first order reaction. Here cane sugar is there. Water is the large. This is the excess amount. So rate is not going to depend on that one, which is the excess, because its concentration is constant. So rate will be what? Depending on only one molecule, this one. So order is what is? Order is actual order is going to be 1. Experimentally, it is 1. Otherwise, appearing how much? 1 plus 1 appearing 2. But actually following 1. Here they have given the example also they have given. So what is they are finding, that is just you see. When the time interval is there, this one concentration here, then this one, then this one, then this one. After calculation rate, they are finding what? 1, same. Here is they are finding same. Here they are finding the same. Rate they have calculated by formula. You can see this formula. This formula, na first order reaction we have done. So they got the rate. So what the conclusion? It can be seen that KH2O is constant and equal to this one. And hence, due to first order reaction, we can now determine K. So that is what we are going to find. This is what? The K is during the constant, means it is not depending on the water molecule. It is depending on the concentration of only one reactant. This is the solution.
Yes, sir.
This is the concentration of what they have given, K minutes. Okay. KH2O 2 point, this one is coming. KH2O 2 point, this one. K dash, that is not required. Means this is the constant I am saying just. These are all the questions we have already solved this one. Temperature. Tomorrow this chapter will be 100% going to be over. Some of the exercise question I will solve here. Whichever you will feeling the difficulties to solve. Remaining question you practice, and those questions which you cannot solve, just tomorrow we will practice these questions, right?
Yes.
Is there tomorrow school for you?
Yes, the school is there.
Then you better you take dinner. Have you taken?
I'm not taking, sir.
Go and take the dinner. Better take rest. Tomorrow is good. Tomorrow you join again, na? Tomorrow you join again 9:30.
Yes, sir.
Tomorrow is the Friday. There is no problem, na?
No, Friday, no, sir. Friday 9 p.m. will be class. So Saturday I will be done.
Then okay. Then we will finish on the Saturday, right?
Okay.
Okay. Bye. Bye. Bye.
Done on Saturday, sir. Friday there is the maths class.
Okay. Okay. No problem. No problem.
Thanks.